Chapter 1 Solution, 12th Chemistry, and we have important questions for board exams. Let us see. Solution having equal osmotic pressure are called isotonic. Which of the following does not show positive deviation from Raoult's law? This is solution of benzene and chloroform. On dissolving common salt in water, boiling point of water increases when blood cells are kept in solution having higher osmotic pressure than the other, then they shrink. According to Raoult's law, the relative vapor pressure depression for a solution or non-volatile solute is equal to mole fraction of solute. The semi-permeable membrane is chemically copper ferrocyanide. Which of the following is a colligative property? Osmotic pressure. In a molar solution, 1 mole of solute is dissolved in 1000 gram solvent. Molar properties are osmotic pressure in the option. An ideal solution is one which follows Raoult's law. Molar properties of solution are based on number of solute particles. The molarity of pure water is 55.6. The formula for finding osmotic pressure is pi equal to nRT upon V. The original formula is CRT, but concentration can be written as N upon V. So this option is correct. The ratio of the observed value of the colligative property and the theoretical value of the colligative property is called want of coefficient or want of factor. Now the question of pattern is fill in the blanks. The value of want of coefficient showing the normal state of solute in solution will be equal to 1. The expression for relative depression in vapor pressure is P naught A minus PA upon P naught A. The number of moles of solute in 1000 gram of solvent is called molality. Only molecules of solvent can pass through semipermeable membrane. The boiling point of water decreases at high altitudes because atmospheric pressure decreases at high altitudes. The molality of water is 55.6. Soda water is a solution of carbon dioxide and water. The number of moles of solute present in 1 liter solution is called molarity. Now, question pattern is one word or one sentence answer. What is unit of molality? It is mole per kilogram. What are those properties of any dilute solution which depend on the amount of solute present in the solution is called colligative property. Write an example of non-ideal solution with positive deviation. It is acetone and benzene, and it can be written as CH3CO CH3 plus C6H6. Write an example of non-ideal solution with negative deviation. This is acetone and chloroform, and it can also be written as CH3CO CH3 plus CHCl3. Give an example of antifreeze compound. It is ethylene glycol. Write the unit of expressing pollution. It is ppm parts per million. Now we have important question for 2 marks, 3 marks, 4 marks. Chapter 1 solution, 12th chemistry. Question is write formula for want of factor I. This is I equal to observed value of colligative property upon calculated value of colligative property. Define normality. Number of grams equivalent of solute present in 1 liter of solution is called normality. It is represented by N, and the formula is N equal to number of gram equivalent of solute upon volume of solute in liters. Differentiate between molarity and molality. You can also differentiate it with the tables, but I have differentiate it with points. Let us see. First of all, molarity. Molarity involves the total volume of solution. In molarity, gram moles of solute are dissolved in 1 liter of solution. Molarity changes with temperature because volume changes with temperature. Now, next is molality. Molality involves the mass of solvent. In molality, gram moles of solute are dissolved in 1 kg of solvent. Here, volume of solution is not considered. Molality is independent of temperature as it takes mass into consideration. What role does the molecular interaction play in solution of alcohol and water? Alcohol dissolves in water due to formation of intermolecular hydrogen bonding with water, and you can write the structural formula of alcohol, that is ROH, and structural formula of water is HOH. And now you can show the hydrogen binding with dotted bond. This is dotted bond, and they form intermolecular hydrogen bonds, so they dissolve to each other. Why do gases always tend to be less soluble in liquids as temperature is raised? Gas plus liquid equal to dissolved gas. For this, the enthalpy change is negative. Thus, the dissolution of gas in a liquid is exothermic process. Therefore, in accordance with Le Chatelier's principle, with increase in temperature, the equilibrium shifts in the backward direction. Therefore, the solubility of gas in solution decreases with rise in temperature. State Henry's law. This is Henry's law. According to this law, the mass of gas dissolved per unit volume of a solvent at constant temperature is proportional to the pressure of gas with which the solvent is in equilibrium. Let in unit volume of solvent, mass of gas dissolved is m and equilibrium pressure is P. Then the Henry's law can be written as m proportional to P, where is in after proportionality sign, it can be written as m equal to k, where k is Henry constant. What are colligative properties? The physical properties of solution, which depend on the number of total solute particles present in solution, are known as colligative properties. Next question, on dissolving ethanoic acid in benzene, experimental molecular mass of ethanoic acid is generally found to be double. Why? On dissolving ethanoic acid in benzene, it dimerages due to formation of hydrogen bond. Thus, its experimental value is generally found to be double. And you can write the structure of ethanoic acid in dimer form. You can also represent ethanoic acid in dimer form, and this is the structure. Now the question is, what is Raoult's law? Establish its mathematical expression. What is Raoult's law? How can molar mass of a non-volatile solute be determined with its help? So both questions are same. Now see the question and answer. Raoult's law states that at any constant temperature, vapor pressure of solvent collected above the solution of non-volatile solute is directly proportional to the mole fraction, and we have mathematical expression. This statement can be written as P equal to PA proportional XA. The pressure of solution is equal to pressure of solvent, so P equal to PA. Now we remove proportional sign and we take proportionality constant, that is PA equal to K into XA, where K is proportionality constant. Applying equation first for pure solvent, XA equal to 1. The mole fraction of solvent is 1 for pure solvent, and the pressure of the solution is equal to the pressure of solvent. So XA equal to written as 1 and PA written as P naught A. Then by putting value we get here PA equal to P naught A and XA equal to 1. So P naught A equal to K, and we get second equation. Now putting the value of K from equation second in equation first. So now PAE is written as PA, K is written as, this is value of K, P naught A, and XA is written as it as. This is equation third. Now, where XA is the mole fraction of the solvent in the solution, the mole fraction of solute is represented by XB. XA plus XB equal to 1. The mole fraction, total mole fraction of a solution is always 1. So XA plus XB equal to 1. Now we transpose XB. Then we get xa equal to 1 minus xb. From equation third and fourth, this is fourth equation, this is third equation, we take pa as it is. P naught a is copied here, and xa, value of xa is called 1 minus xb, so it is written as 1 minus xb. Now p is multiplied with 1, then we get p naught a, and p naught a is also multiplied with xb, then we get p naught a. Now this term is transposed to here, and this term is transposed to here, then we get this, and we find xb, so it is transposed to p naught a, and this is the formula mathematical expression for Raoult's law, and it is also equal to the mole fraction of solute particle. Next question is, give relation between elevation in boiling point and molecular mass of solute. Now relation between elevation in boiling point and molecular mass of solute. Suppose Wv gram of non-volatile solute is dissolved in Wa gram of solvent, and the molecular mass of non-volatile solute is Mb gram, then molality M will be. This is the formula of molality. Here this is Wb upon Mb. It means it is number of moles, and number of moles can be found by weight of solvent upon molecular weight of solvent, and this is weight of solvent into 1000. For any non-volatile solute from elevation in boiling point, delta Tb equal to Kb into M. From equation first and second, we put the value of M, we get delta Tb equal to, this is Kb and this is value of M, and we get the formula. On transposing Mb and Tb, we get Mb equal to Kb into Wb into 1000 delta B into Wa. Thus we get the formula for molecular mass of solute through the elevation of boiling point. And now the question is, write three differences in ideal solution and non-ideal solution. Difference between ideal and non-ideal solution. Ideal solution, they obey Raoult's law. Non-ideal solution, they do not obey Raoult's law. This is Raoult's law. There is change and enthalpy that take place during the formation of solution, that is delta H mix equal to 0. There is no change. For non-ideal solution, there is no change in enthalpy that take place during the formation of solution. There is change in volume during the formation of solution. There is no change in the volume during the formation of solution. ये उल्टा हो गया, इसको आप देख लीजिएगा। इसमें देखिए थोड़ा उल्टा हो गया, फर्स्ट पॉइंट भर सही है, बाकी ये नॉन आइडियल के लिए ठीक है। ओके, write 5 differences in solution having positive deviation and negative deviation, and this is the difference. Vapor pressure of solution and the partial pressure of the components are more than those expected by the Raoult's law. This is positive deviation solution. Vapor pressure of solution and the partial pressure of the components are less than those expected by the Raoult's law. Delta H mix is not equal to 0 and it is positive. Delta H mix is not equal to 0 and it is negative. Delta V mix is positive and delta V mix is negative. Forms minimum boiling azeotrope solution, forms maximum boiling azeotrope solution. On mixing, intermolecular attraction decreases. On mixing, intermolecular attraction increases. And the example is acetone and carbon disulfide. This is acetone, chloroform and acetone. You can also write in words. Now this is numerical question. Calculate the osmotic pressure in pascals exerted by solution prepared by dissolving 1 gram of polymer of molar mass 185,000 in 450 ml of water at 37 degrees Celsius. Now we have the formula for osmotic pressure, P equal to CRT, and we have, there is no concentration in the question, so concentration can be written as N upon VRT. Here N equal to 1185,000 gram per mole, this is the value of N. V equal to 450 ml, this is V equal to 450 ml, and temperature 37 degree can be written as an absolute temperature, that is 37 plus 2073 273 equal to 310 Kelvin, and the ideal gas constant is R equal to 8.314 K Pascal. It cannot be given in the formula, you have to learn it. Now putting the value in the formula, we get, applying the formula, this is value of N, R, this is value of R, this is value of T, and this is value of V. So on calculating, we get 30.96 Pascal. Next numerical is Henry's law. Constant for the molality of methane in benzene at 298 Kelvin is 4.27 into 10 to the power 5 mmHg. Calculate the solubility of methane in benzene at 298 K when under 760 mmHg. Here Kh, Henry constant, is 4.27 into 10 to the power, that is, and pressure is 76 mmHg. Applying Henry's law, here Henry's law, P equal to Kh into x equal to P upon Kh. Value of P is 760 and value of Kh is 4.27 into 10 to the power 5. On calculating, we get 1.78 into 10 to the power minus 3. The small fraction of methane in benzene is 1.78 into 10 to the power minus 3. Now next question is, if 6.84 grams sucrase is dissolved in 100 ml solution, then what will be its osmotic pressure at 20 degrees Celsius? Here R equal to 0.82 liter atmosphere per Kelvin per mole. Molecular mass of sucrose Mb is equal to 342. Here given weight of solute, that is Wb equal to 6.84 gram. Molecular mass of solute is 342 grams. Mb equal to volume of solution, this is 100 ml and it can be written in liter, 0.1 liter. Temperature T equal to 20 degrees Celsius and it can be written in Kelvin, 273 plus 20, this is equal to 293 Kelvin. Solution of constant R is 0.82 लीटर, ये वैल्यू हो गई इसकी R की. Osmotic pressure, we know that pi equal to CRT, but concentration is not given, so it can be written as N upon V RT, and number of moles can be written as Wb upon Mb. By putting value, we get the value of Wb is equal to 6.84, this is value of R 0.82 and value of T 293. Here value of Mb 342, value of V 0.1. On calculating this value, we get 4.8 atmospheric pressure. This is the value of osmotic pressure. And these are the important questions for the board exams. So you practice it, share it and subscribe it. Thank you.